Welcome. In this video, we will talk about how to program an electric sequencer in a PLC. A sequencer is a way to perform an ordered series of steps. So for example, we have step 1, in which we perform some actions. Then, when something occurs, we go to the next step. This will be called transitions, which are the conditions when we go from one step to the next. We can have as many states as we want. This here is called a state diagram, and it's a crucial part for this methodology to work. You have to design this diagram for a specific automation situation. So imagine you are asked to perform the next sequence. Clap for 5 seconds, sit down, and whistle 2 times. Think, which are the steps? Which are the actions? And which are the transitions? Give this a few seconds, pause the video, and see for yourself if you get it right. Hopefully you reach the following. We have 3 steps, which are the numbers. The actions are clap, sit down, and whistle. And the transitions are 5 seconds to go from step 1 to step 2. Wait until you sit down to go from step 2 to step 3, and count 2 whistles in order for step 3 to end. So once you've determined the diagram, the following program organization is recommended. Start conditions at the beginning, states, transitions if needed, and actions at the end. Although some PLCs can be programmed by a language called GraphZ, most can't. So we'll focus on making this program in a ladder language for PLCs. The start condition is basically a line where we'll list in all the conditions required for our sequence to start. This will look something like this. The states are the memories of all the required steps. Notice that we will use a reset dominant type of memory. The transitions may not be needed, but if so, they usually contain timers or counters to help keep track of when we need to change from one state to the other. And finally, we have the actions, where we will simply relate the states to the desired outputs of the sequence. Now, what about the Boolean equations in our program? So for the start conditions, we will have all the actions that are needed to start the sequence, but we will end them with the condition that not any state will be on. So what this means is that not any step should be on, and the action should be present in order for the start condition to be triggered. For the states, as I said before, we will use a reset dominant memory, which is that equation. For the set condition, the previous state should be on, and the previous transitions should occur. Also, I've added the start condition, but be careful. This start condition should always be only programmed on the first or the beginning state, which in this case is step 1. For all the remaining states or steps, we will not program the start condition. And for the reset, we will use the next state. So let's give it an example. For this example, we will look at step 2. For the step 2 to be on, the step 1 should be present, but also the transition 1. So when these 2 conditions occur, the step 2 will be on. Now the question, when will we be turning off the step 2? When the step 3 turns on, then we will turn off the step 3. That is what these equations mean. Now for the transitions, we need to configure the timers or the counters or anything that needs to check if something has occurred for a state to end or start. Finally, for the actions, well, the equation is pretty simple. We will simply put the step in which the action needs to be performed, but also we need to end it with not the next state. The reason for this is because there is one point in which 2 states will be on. For example, when we are in step 2, the step 2 will be on, and then the step 3 will be on when the step 2 is on and the transition tree occurs. At that particular moment, both step 2 and step 3 will be on. And after a little time, because remember, the off condition for step 2 is that step 3 is on, so the step 2 will turn off. But again, at a very specific time, both states will be on. So we want to make sure that the action is performed only in step 2, not when both step 2 and step 3 are on. So let's see an example. We have 3 steps, but unlike the previous slide, notice how we have something that is recurrent or cyclic. We go from step 1 to step 2, from step 2 to step 3, and from step 3, we return to step 1. An important part to mention is that we need to do something with the start condition. So maybe we can say that a button will turn on the step 1 for the first time. This is very important. So what does the program look like? Well, for the start condition, it will be the button. But also remember that even if this is the only condition for the program to start, we need to put not any state on. So we're going to put step 1, not present, step 2, not present, and step 3, not present. When we have this, then we activate a coil, which we will call SC, which is a start condition. This coil can be a memory. For instance, for Siemens, we have M0.0, and for some Allen Bradley's PLC, we can have something like bit 0.0. Next, we will program the step 1 memory. So for the step 1 memory, what we do is, again, a reset set memory. So the reset condition for step 1 is the next state, which is step 2. So for step 2, we will put the reset condition, which is step 2. Okay? Now we put the set condition. Now the set condition for step 1 is the previous state and the button. Now notice how we have the same button. Okay, so be very careful. I'm going to put here the previous state, which is step 3, and the transition, which is the button. So when those two are present, we're going to turn on this memory. But if you remember, for the first step, we will also put the start condition, because otherwise this machine will never work. And also we will need to latch this memory, which is of course step 1. So what I'm going to do is I'm going to put step 1 here also. And at the end of this program, I will put a coil with step 1. This is the way we program all the steps. Okay, so below here, we would put another row, and I'm going to help you with the reset condition. For step 2, the reset condition would be step 3. You will need to put something here, and of course it would be the program for step 2. And then you would need to program the condition for step 3. So again, start conditions and all the states. Next, we need to program the transitions. And for the transitions, well, we need to program, in this particular case, one timer here, another timer here, and for the button, if you remember the button, we program this transition directly on the ladder diagram. If you're not sure of this, I suggest that you go back some seconds on this video and rewatch that part. So after the transitions, I'm going to put a timer. Now, when do I want this timer to count? Well, I want to count when I am in step 1. So I'm going to put here the step 1, which is the signal that will turn on the timer. And when the timer ends, which I'm gonna say that this is a timer 1 maybe, well, this timer 1 should go, this signal should go into the set condition of step 2. Okay, so the set condition of step 2 is step 1 and timer 1. You need to do the same thing for the transition of step 2. You need to program another timer that counts 2 seconds. Okay, so you will have another part of code where you program the second timer. In this case, timer 2. And again, this should be on the set condition of step 3. And finally, we will put the actions. For the actions, if you see we have 2 different actions. Or you can say that we have 3, but in step 2, I don't want to do anything. So for step 1, or in this case, we will focus on the output, which are 2. So you need to program 1 line of code for the motor and 1 line of code for the light. For the motor, notice in which steps you turn on the motor, which is in step 1. So what you have to do is you will simply put step 1, but remember that you will put that since step 1 and step 2 will be on for a brief period of time at the same time, you want also to put that it should not be on step 2. So when these 2 conditions occur, we want to turn on the motor. For the light, however, when we want to turn on the light, well, the light we will turn on step 1, but also on step 3. So for step 1, we will say, okay, we want to turn on step 1, but remember that we want to turn it on only when it is in step 1, not on step 2, but also when we are on step 3. But in step 3, we have step 3, but also that it is not on the step 1, which is the next state. Because again, both of these states will be on for a brief period of time at the same time. So that's it. Hopefully you've understood how to program a sequence in a PLC. Thank you for watching. See you next time.